We have Ed Page on deck, who is a member of the cargo team, maintains Clap, Winnow, many other things. I'm sure he can tell you all about them later. And he's going to give his talk, Performance, We're in This Together. Please make him welcome.
So first I have to say that with the career field I chose, I never expected to be presented on the silver screen. So that's quite an honor to um, be there. So when I put this idea forward, this was like, oh, this is just going to be a small presentation to the project members. So I didn't really put too much thought into it. That's a very ambiguous title. What kind of performance are we talking about? Well, when I proposed this was to the all hands. This was for us what our performance we're presenting out to the user. So this is actually about build performance, about how fast can we make builds, how can we make things better within Rust and the overall ecosystem. So overall performance has been getting better in Rust. There's been lots of really great improvements. There's been lots of just small incremental optimizations done over time. There's been incremental compilation. There's been pipelined builds. There's been parallel backend. Those have all done a lot of good work to be able to make things faster. Unfortunately, that is not enough. When Rock was looking at their rewrite, they decided to switch from Rust to Zig, and it was because of the compile times. If you want to have more discussion on this, Richard is actually right over there, so maybe he can be part of the QA afterwards. People aren't needing just 1 or 2% performance improvements. People are needing to have orders of magnitude performance improvements. But there's also one problem with this quote from Richard. The fact that as somebody who uses Zig actually pointed out that Rust actually has better compile times than Zig right now. So Richard actually clarified that this isn't actually about Zig's compile times right now. It's about the fact that Zig has plans to dramatically improve their compile times, and he trusts them to actually deliver on it. Before Rock was even started, we've been talking about the crane lift backend. We're still talking about the crane lift backend. That's not to rag on the crane lift effort in of itself or any of that kind of stuff, but just how are we reflecting on how are we doing as a project and be able to build trust that we can actually make those dramatic improvements and be able to deliver on them for people. And it might seem like, okay, lock for lock, line of code for line for code, we might be on par with C++. That might be a reasonable thing to be able to say, and that's a good place to be for performance. Except that there's non-C++ developers out there who are wanting to use Rust for various reasons, and the bar is set much higher for them, ridiculously high, so high that it doesn't make sense for us to actually match it, but that's where the expectations are at, like, say, the Python users for the Astral people. And also, even for the C++ developers, if I'm writing a game using the Unreal Engine, am I recompiling Unreal every time I do a make clean make? No, I'm only remaking my own things. But if you're using Bevy and you do a cargo clean cargo check, it's rebuilding Bevy. And so there's just a whole different approaches being taken here that when we talk about our build times might be on par with C++, that's not good enough. So what do we do about this? So to talk about that, we first need to make sure that we frame our discussions about performance in terms of the user and how this impacts the user. Us tracking performance is important. Us being able to see these 2%, 5% performance improvements is important, so we also don't have the opposite where we slowly degrade performance over time and not realize it. However, this is not how the user thinks. The user is reacting to the performance. If things take too long, they might go and they might just be annoyed if it's taking longer that they notice it. Or they might be like, okay, this is taking a bit longer. Maybe I'll go check things on Reddit. Oh, this is taking longer. Maybe I'll go for a coffee break. This is taking a really long time. Maybe I'll just start working on another project while I wait for the results for it. So you find that performance measurements for users are discrete, and there are huge orders of magnitude between them for what reaction the user gets. Because even if you make it like 10% faster within one of these workflows, the user is still off doing something else, and they're not going to notice because they're distracted with something else. You've lost their attention. And so you need to make it so you can make things faster such that you never lose their that you bring their attention back into a smaller area of losing their attention. But what kind of user reaction? What are the users reacting to with this that they might be going through these different stages? Well, this is about the user's workflow. What is the user doing? They might be iterating on errors and warnings, lints, making their code nice. They might be iterating on a test, getting it working, getting the results they want from it. They might be doing some exploratory programming, or they might be waiting for CI. And then one that's completely unrelated to us, they might be waiting for a reviewer, and that might actually end up being the real tentpole in this whole situation. But we also have to keep in mind that we have to dig deeper into each individual one of these, because it's that benchmark I was showing you for rustc was for if you make an edit to a leaf crate, how long does it take to rebuild that leaf crate? Well, if you look at Zed, the text editor, they have over 150 workspace members, and their dependency tree goes about 9 deep. So if you're making a change to something 9 levels deep, what's the build times of that bubbling up through the rest of the stack for incremental compilation or for other things that you're doing? And so we need to be thinking of performance, not just in terms of the simple, easy to measure cases, but we need to talk to users about how all these things are interacting with each other. We also need to talk to users about what problems they're running into with all this, because it turns out like one of the problems that Zed was having when we were talking with them was sometimes everything rebuilds. And it doesn't matter how much you improve incremental rebuild read time if you're also rebuilding all of your 1,000 dependencies. And that's because Cargo and Rust Analyzer were fighting over some settings that they had, and it was a suboptimal case in Cargo's caches. After a conversation with them, I went and fixed that so it was less of an issue. Another issue you run into when talking to people about this is they're usually jumping around in different parts of a workspace. They might be making a change in one spot and be like, oh, I need to make a change over here also as part of this whole effort of what I'm doing. And they'll have different features activated for all their dependencies, and things will get rebuilt again. Woohoo! So no matter how much we speed up the compiler, if we're doing these full rebuilds, it's not going to make much of a difference. So we need to look at the overall workflow and what all problems people are having through this whole process. So we need to talk to users. We need to have these opportunities to do this. Like that was really great that Nico set up that call with Remy and I to be able to talk with the Zed folks, the Rock folks. I'm pointing to the same people because I didn't realize they're the same people, and others to be able to hear about these kinds of problems that they're having. What's going on in their workflows? What's things slow? It's like some of the questions we brought up with them. Some of the things I expected to be a problem for them turned out to not be. Like there's different work problems because it's like there's incremental builds, but there's also CI. Depending on your caching, you might get full builds. How much of a problem is CI? How much of a problem is this? Being able to iterate through those kinds of conversations was really useful. And when talking to users, one of the things that's important is to ask them, what are you avoiding? What is it or what are you working around? Because this is an example of MacClad was giving ideas on how to improve your build times. And he was just like, abandon doc tests. Don't even use doc tests. They're just too slow. Well, that's a great thing to be able to dig into to better understand why they feel that area is slow, because that could be a rich area for finding optimizations. And that's exactly what Guillaume did with the 2024 edition, where it's not just 2 or 5% performance improvements. This is orders of magnitude improvements in times. This is changing how a user is reacting. I mean, looking at that GIF time going from 4 minutes to 7 seconds, that is dramatic. So that's what we need to be looking at, is having those conversations about what are people avoiding, because you might miss things if you don't have those kinds of conversations. When inside the project, when we have these conversations, we also need to not be afraid to go out into the ecosystem. This is something that was really inspirational to me from Nick Nethercoat up over there, where he was trying to optimize declarative macros, and he just hit a point where he couldn't find any more optimizations. But he looked at the ecosystem and found that they're more people are writing macros that are more algorithmically complex than they needed to be. And he was able to just identify a few declarative macros within the ecosystem. They have improved those. They dramatically improved the build times for a whole bunch of crates, because a whole bunch of crates depended and used these declarative macros. And so we need to not be just afraid looking at how we can improve performance within the Rust project, but how are people using it, and should we actually be trying to find ways to be improving things in the ecosystem, just core load-bearing crates to be able to make it so we get this benefit everywhere. Actually, I forgot to also mention that he didn't just improve those macros. He then went and updated the little book of macros to have it talk about these trade-offs. So that way it'd help people in the future writing new macros to be able to improve the situation. So in all of this, there is areas that we could be able to have where the potential improvements are unexpected, where things might be indirect, where one team might have something that's kind of in their backlog that they've been kind of meh about, but there might affect another team in a way that can dramatically improve a user's performance. And we need to have conversations to be able to be aware of these kinds of things. For example, if Teeling was able to move forward with implicit mod statements, that could actually improve performance. That might sound like a really strange thing. This is just a usability feature to reduce some of the clutter from code. So why does that improve performance? Well, back to that MatClad blog post, one of the things he talks about is when you write your tests, your integration tests, you put them in individual files, but then Cargo will build those as individual binaries and link those as individual binaries. And so you're now linking 20, 30 separate times, and link times can be dramatically slow. Granted, I before said be careful about what you're avoiding. So this might be also one of those cases where, hey, it'd be great if we improved link times. They're working on improving link times. There's things to improve link times even more in the future. So maybe this is one of those cases. But what MatCloud was recommending was to combine everything into a single integration test binary. But when you do this, you have to manually mark all of your test mods inside of your main.rs. That's just annoying to do, and it's error prone. It's very easy to accidentally leave out one of your test modules, and it just never gets run, and you don't realize it. So it's hard to be able to recommend this workflow to users, say in the Cargo book, or to try to find different ways to try and push people towards this if people have to manually be specifying all of their modules. Again, I'm not saying necessarily that an auto mod type of a feature is like saying hey, I'm just kind of like doing a backdoor passive aggressive way of saying, hey, Teeling, you need to be doing this. But it's just to be able to say, this is an example of something that we can do where there's these indirect effects, where maybe we should consider this more than we might have otherwise, just because it has these effects on how people are behaving and how we can be able to take advantage of that. Another kind of surprising one to think about, probably a little bit less so than that last one, is about there's a feature called config version and config accessible, which allows you to conditionally compile your code based off of what version of Rust you're currently using. And these can affect performance because there's many crates out there that want to be able to conditionalize themselves off of these things for being able to lower their MSRV. And in doing that, they're pulling in build scripts, they're pulling in proc macros, and it's slowing down your build to have to build those. There was a blog post, I think it was a week or two ago, where somebody was just frustrated, where it's just like, I had to just 5 dependencies to create this web server, and transitively I had 1,000 dependencies and was doing all these horrible types of things. So I went and reproduced his situation, and that was actually one of the things I found in that situation was they had, in their dependency tree, they had two different crates in the dependency tree for getting the Rust version. One of those used a proc macro, and then the other one was set up where you had to write your own build script on top of it. And so there's just this propagation of all these build scripts and proc macros through the project that dramatically slow down the build times because they're having to be linked, they're having to be executed, and all that kind of stuff. That if we just had these one or two features, we could cut all that back and be able to improve their build times. There's also some other terrible things, like they had 2 separate copies of requests in their dependency tree, but that's a whole separate topic from this one. And a similar story for other features, like there's a config alias RFC up right now, and that was another thing where when I was looking through some build scripts recently, I was finding that that was one of the things that they're spending a lot of their time in their build scripts was just setting up all those aliases. Not that that's complex logic that's going to slow in of itself, but just the time it takes to build and link all of the build scripts can really slow down everything else. Another area that's important for us to be considering in the project is when there can be competing improvements. Where if we do 1 or 2 improvements on their own, they'll work great. But if we actually do them both at the same time, they might actually cancel each other out and waste a whole lot of effort and frustrate people. So I'm going to just run through a couple of examples that highlight different aspects of this. So proc macros, I've already mentioned, those can slow down your build for various reasons. But there's some improvements that we can be able to do to these. There's a PR up right now for caching the results of the proc macro being expanded. There's also been some more hand-wavy brainstorming of what if when you do cargo publish, it actually snapshotted the expansion of the proc macro and was able to cut all of your proc macro dependencies and just be able to move along like that and be able to fully cache it and not have to build anything. That would be amazing. Or what if we're able to stabilize more features so we're less reliant on third-party creates that take a long time to build so that we can be able to then do even more things, be able to improve performance even more. That would be awesome. And also, proc macros, just to be aware of, have some other problems. We don't really have good input tracking for proc macros to know when rebuilds should happen because they can do anything on your system. They can go talk to a database. Yeah, that's a fun one, which, talking of, they're running arbitrary code, talking to databases, going to the network, doing all sorts of things. And they also lack a feature of declarative macros called, that's just the syntax is $crate, which allows you to say, for the API I'm generating code against, let me know how to reference that inside of the code I'm generating. So there's some downsides and trade-offs to proc macros. But one other avenue of this is Josh has some RFCs up for improving declarative macros so that you could be able to use them in the place of derives and attributes. Places where you'd use proc macros today, maybe you could actually use declarative macros. So if we could have those derive and attribute declarative macros, that'd be great. But they're difficult to work with. We'd need to be doing other things like improving some of the pattern matching so we can easily match a struct and be able to do different operations on a struct. And this also solves some of those problems that we have with proc macros today. They don't have the $crate problem. They don't run arbitrary code. We are able to track their build inputs because they don't run arbitrary code. So there's some really good advantages to taking this approach. There's also some ergonomic problems. That's understandable. But this could probably replace 90% of people's proc macros to the point that you could actually reasonably have a project where there's no proc macros running in the entire project. That would make a huge difference. But I'm also really curious about an experiment that Amos is doing, Faster Than Lime, where he's actually working on a generating reflection information so you can be able to introspect on the what your struct or your enum or whatever else is doing and be able to then perform runtime operations based off of that. So no meta programming, no code generation is being done with this, but that can still offer a lot, has a potential for a lot of really great applications. The main limitation is it only helps you with the use case of declarative macros. It doesn't help you with attribute macros or function macros. And you can't necessarily do some of the same kinds of compile time transformations that you can do as in a proc macro. You can't necessarily take a field name and case convert it so instead of underscores it has dashes. That way you can use it and have a properly named command line flag, unlike some places where they use underscores instead of dashes. That always rubs me the wrong way. But this is an example where we could have multiple competing avenues. Like, yes, we could do all of these. That would be amazing if we could just improve everything and that'd be okay. But that takes a lot of time. That takes a lot of our focus. There's especially core teams that this depends on, like say the Teeling, where just they have limited time for being able to even work through some of the decisions that have to be made for some of these to be able to move forward. So we need to be able to talk, focus, and prioritize on what we're working on so that we can actually make forward progress rather than just being so distracted that the teams that we need to make decisions are constantly context switching between all these different proposals we're trying to push forward, and everyone's moving forward like inches at a time rather than us be able to work together to be able to move forward more dramatically. Another example of this problem with unexpected competing needs is caching. There's interest within the cargo team for being able to have cross workspace caching. people hack this together today by just saying two projects, hey, use the same target directory. And then occasionally they run into problems with that, like binaries overwriting each other and so on. But if we actually had a more native support for that, where we could actually better track everything that's going into that shared cache and handle everything coming in and out of it, that'd be great. And maybe we could add remote caching for this in the future. So that way you can go to a cargo, say you're going to contribute to cargo, you can say, I trust cargo's CI and automatically download things from its cache and use it. And you now have access to, when you do your get pull, you can then also have it automatically pull things from the cache, and you're just all of your dependencies have been built already on this cargo CI, and you can just get up and running and immediately go. That would be amazing. Granted, there are issues with build scripts and proc macros that we'd have to figure out through all this. We might actually have to skip those in the first version of this when we get it out. And another problem is if you have a group of dependencies, so say you have a proc macro and a new version of Sin comes out and you have two different projects with proc macros. They have different versions of Sin, but everything else is the same. But that basically creates a whole new entry for everything above Sin for the cache. And so there's a lot of reuse things that you run into with this. Like maybe there's a kind of a concept I've been playing with called opaque dependencies, where it's like you can say for a subset of your tree, like go use all the same version of your dependencies of like use say clap, like use clap's lock file, keep it all consistent. Like if you use one version of clap, you get all the same versions of all the proc macro stuff, and you're good. And that doesn't affect me. So that way you can have better caching between different kinds of dependencies. And note in this, I'm talking about caching of things that are built. I'm not talking about pre-built packages. That's something that people are quick to be able to say, like, oh man, that'd be great if there's pre-built packages like that you see on PyPI or in other places. Well, that's because there's differences here. With cargo, there's an expectation of transparency for within the top level application that has full access to control everything for its transitive dependencies, that it chooses, that the top level application can choose what version is used for anything, or patch out a transitive dependency and say, I actually have a bug fix for my particular application or something my specific project needs that needs to be slightly different. You also have the different scenarios, like if something's pre-built, you have no control over what profile is used, and if you want to pass special Rust flags, you can't do that in that kind of a scenario. But when you're on PyPI, you're in a scenario where, well, you're all in Python and that's all in C, like that's all opaque to you. That's all hidden from you. You don't see those no matter what, whether it's pre-built or not, so you don't care about those kinds of details. And again, that's maybe where like the idea I said of opaque dependencies might be useful, is like, well, maybe we can like say all of this is shoved off and hidden from you, kind of like say Python pre-built packages, and maybe that could be able to help in the situation. But that's a whole new concept that we'd have to work out to be able to get there. But talking about any of this kinds of caching work that we might do, there's another concept that's been floating around that's mirror-only rlibs. So you can think of the compiler split into two parts, front end and back end. And mirror is, I believe, the communication layer between these. Feel free, any of the T-compiler people, to correct me in any of the things I say wrong in this part. And so what mirror-only rlib would do is, instead of performing the front end and back end for every single crate as you bubble up the stack, only do the front end work and save that off. And then in your final application, it takes all the front end information, all the mirror, and then does the code gen all at once. This has a couple of advantages because back end can be really slow. So if you can reduce the amount of stuff you send to the back end, you can speed up your builds. And there can be situations where if you have a vec u size in two different crates, that'll be sent to the back end twice. But if we do mirror only rlibs, that'll then be sent to the back end only once. Similarly, this allows an extra form of dead code elimination. If there's something that has code gen performed on it, but it's not actually used in the top level application, we will now no longer do that code gen. And there's actually a step further from mirror-only rlibs that we could be able to do. The Zig has a compilation model where they'll do, I think it's approximately generating an AST, and then they stop for all of your dependencies. And then what they'll do is they'll take the entry point of your application. So if it's a binary, they'll take your main. If it's a library, they'll take all of your pub items. And they'll just recursively descend from there, only generating effectively the mirror and then eventually code gen for only the things that are actually reachable from your entry point. And if we have any of these kinds of models, we're basically talking about doing a lot of the compilation process at the very end to be able to make that faster. But if we have caching, we're caching the stuff that happens before that. And so if we're reducing the amount of stuff that we're caching, if we're reducing the amount of work that we're caching, we're losing a lot of that benefit of the cache. And caching can come with an overhead cost. And so if we did both of these together, would we actually basically make it so the cache is useless and we just wasted a lot of time trying to work on that? That's why it's important for us to be able to be coordinating and figuring these things out so that way we can make sure that we don't have two teams working cross purposes from each other. Oh, hey, that picture did not load. I wonder why that's broken. Oh, I think I actually forgot to commit that to my blog. The fun thing about doing things locally versus online and forgetting to get ad. Hey, that's another plug, JJ. You should probably use it. I'm not using it, and that's probably my fault. So this is supposed to be the picture of the beam of the guy where he's just like, and there's like all of the threads everywhere of like the things he's trying to map out. So I don't know how much it fully came across, but as I was talking about these things, it's like trying to track, here's this project and here's this project, and here's how this thing might affect this thing, and thing might affect this thing, and how this team is doing this, and this team is doing this. It's complicated. Hey, that at least is up there. And we need to unravel all of these threads so we can be able to figure out what direction we can even go in, so be able to make it so we can actually commit to people about, hey, like, yes, we can't fully commit because we don't want to do death marches. We want to make sure that we don't burn people out and all that kind of stuff, but people can actually trust us to be able to deliver on things. And so we need to talk to each other within the project. And as part of that, this talk is really a primer for my all hands session at Saturday at 9:30 to make so that way one is, hey, make sure you know to go to it, and then two, make sure that we have some of the background set up for it so we can be able to get started in talking about this. And there's a lot of ideas of things that we could be able to do. Again, the huge screens make it so these kinds of things are not as overwhelming as you would expect, but I actually don't even have all of my ideas up here because there's some things more smaller down, focused on cargo that are improving performance for some very specific workflows, but it's a pretty good sized list. And so yeah, we need to also be able to hear from you all about what ideas you have and be able to add that to the list and see how we can be able to coordinate on these things, be able to help things, how we can be able to change users' workflows to make things faster. And also, I can't do all this myself. Even all the things in cargo I can't do myself. I'm right now, my focus, well, I'm getting myself distracted again. I should be working on actually improving cargo test, but I'm distracted by a performance thing that's not on here. Once I'm done with that, I'm going to be focusing back again on cargo test. So I can't do this. We need people to come in, step up, and be able to help with these things. Like one of these, bottom middle is faster dev profile. Find a way to be able to broke the Gordian knot about the fact that the dev profile is both meant for iterative development and it's meant for debugging. And a lot of times those two workflows are actually separate, but we're slowing down people's iterative development in case they might at some point use a debugger. There's a lot of things that we need to figure out about backwards compatibility and all that kind of stuff to be able to split those things out. We need help, and people, it's not that it's going to be necessarily a hard problem, but we need people to actually just think through these things and consider the corner cases. So we need a lot of help to be able to get any of this moving forward. So if you're wanting to dig in and be able to make Rust faster, here's a lot of great ideas to be able to do so. And thank you very much.